So this video today, we're going to go over proving triangle similarity by angle, angle, side, 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 and side, angle, side. So there are several ways to prove certain triangles are similar. The following postulate, as well as side, 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 and side, angle, side similarity theorems, we will use to prove just as side, 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 angle, angle, HL, and angle, angle, side were used to prove triangle congruence. To prove certain triangles are similar, use one of the following postulates or theorems. We're going to start with angle, angle. Okay, so if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So notice here that it shows us that angle A is congruent with angle D, and angle B is congruent with angle E, right? If I have those two angles congruent, then I know the third angles have to be congruent. And remember, we might dilate this, but the angles don't dilate, okay? So angles stay the same. So example 1 says, using the angle-angle similarity postulate, explain why the triangles are similar and write a similarity statement given that AB is parallel to DE. So it's telling us that AB is parallel to DE, right? So since AB is parallel to DE, we know that angle A is congruent with angle E. Why? Because of what? Alternate interior angles theorem, right? And obviously angle A is congruent with angle D because they're both right angles, right? Okay. So therefore, ABC, so let's look at right to one arc to nothing. So we're going to go from right D to one arc E to nothing, C. And they're congruent by angle, angle. Now, obviously, everybody knows that we could have marked, obviously, the vertical angles as well, right? Could have marked these as well, and that would have been my third angle. Could have marked them to begin with. Got it? So either one of those could have been marked, and it would have proved that these triangles are similar by angle, angle. So go ahead and do these two and come back to me when you're done. So this one says, explain why the triangles are similar and write a similarity statement. So by the triangle sum theorem, can't we find angle C? Wouldn't we do that by subtracting 43 from 90? 90 minus 43, because we've already used 90. Isn't that going to be 47? It is. Okay, so angle C is 47 degrees. So what does that mean angle C is congruent with? Let me go ahead and write this here. 47. Okay, so angle C is congruent with angle F, right? And again, we see that B is congruent with E because they are both right angles, right? So therefore, triangle ABC is similar to triangle what? So we went from 43 to 90 to 47, right? So we're going to go 43, which would have been this angle down here, right? So that's D. And then we went to the 90, which was E. And then we went to 47, so that's F. And this, again, was by angle, angle. Okay? Let's see if you guys can look at the last one and figure it out, because we've done stuff like this over and over and over again. So TP is congruent with what? SR or RS, okay? And so P, angle P, is an alternate interior angle to angle R, isn't it? Because both of them have the transversal of PR. So angle R, and then also we have that angle, what? TP again is because it is parallel with SR. We can say that T is congruent with S, right? So again, by the alternate interior angles theorem. By vertical angles congruence theorem, PQT, so now we have one arc at nothing and then two. So we're going to say is congruent to what? RQS, okay? Therefore, again, PQT is similar to RQS. We already wrote that up there, so we're good by, again, angle, angle. Now, the reason why we only put two angles, y'all, is because the third angle, if two angles of one triangle are congruent to two angles of another triangle, then the third angles have to be congruent, okay? All right, here's our next two, side, side, side. So basically, if three sides of one triangle are proportional to three corresponding sides of another triangle, then the triangles are similar. So we got these color-coded here. So it's telling us a similarity statement. See it here? So that means AB is going to be similar to what? DE, right? First two letters, first two letters. Then we have BC is going to be similar to what? EF, right? And then we have AC is going to be similar to DF, okay? And we can see that one dot, and we can do this with our 1 dot, 2 dot, 3 dot too as well, right? So there's our 2 dot, and here's our 3 dot, or with nothing, okay? That was my little trick that I taught y'all. All right, so that's side, side, side. So those have to be proportional. Y'all got me? So if 3 sides of one triangle are proportional to 3 corresponding sides of another triangle, then the triangles are similar, okay? Now, with side angle side, you're going to have an angle that's congruent, and then you're going to have a pair of sides that are on either side of that angle. So it's an included angle, right? The angle's included between the 2 sides. Remember, included in between are interchangeable terms. So again, if 2 sides of one triangle are proportional, again, to 2 sides of another, and their included angle is congruent, okay? Key, okay? So we have, again, AB is similar to what? DE, right? DE, okay? Then we have angle B is congruent. Angles are going to be congruent now to E, okay? And then we have the other side down here, BC, is going to be similar to what? EF, right? Yep, you got it, okay? So what do I mean by that? So look here again. We got a 1 dot here, got an arc, and then 2 dots. So we got a 1 dot there, we got an arc, and then we got 2 dots, okay? So now let's look at a couple examples of this. So verifying that triangle PQR and STU are similar. So this time you notice we have 3 sides, right? So again, we're going to take our first two letters, PQ, and we're going to put it over our corresponding ST, okay? So PQ and ST. Those are going to be similar, right? So you could have said PQ is similar to ST because we know that, yes? Okay, so what is PQ? PQ is 3, right? And then what is ST? 4.5. And that reduces to be what? 2 over 3. Okay? Do that in your calculator. You would see it was 0.666666, which is, yeah. So now let's go to the next side. So we're going to do QR and TU. QR over TU is equal to, what was QR? Looks like they are the same numbers, right? 3 over 4.5. So we know this also simplifies to be 2/3. Okay, so now we're checking our last side, okay? So we're going to do PR over SU, right? SU. So PR is 2 and SU is 3. And that can't be simplified anymore. So we've got the same ratio, 1, 2, 3 times. So that means that PQR is similar to STU by side, side, side. Because we got the same proportion for all 3 sides, then we can say that these 2 triangles are similar by side, side, side. All right, our other one, it says verify the triangles that DEF and HJK are similar. So do you notice that we have a pair of angles that are congruent? Right here. Angle, angle. So that's angle D is congruent with angle H, right? So now let's see if we have a pair of sides that are corresponding that have the same ratio. Okay, so we're gonna compare DE to HJ. Y'all see that? HJ right there, okay? So that's going to be DE over HJ is equal to 2 over 1, right? Now let's compare our, so now we have that angle, right? So I'm going to go ahead and write that between here, okay? So we have angle D is congruent to angle H, right? So we have a side, we have an angle. Now let's see if we have a third side. Okay, so we're going to compare DF here. DF to what? Look here again. DF, first, last, HK, right? HK. So we're going here. HK right there. Over HK, okay? So DF over HK is going to be 5.8 over 2.9. If you divide that, you get 2. Just remember that 2 is the same as 2 over 1, right? Okay, so now what did you notice? We had a side, 2 sides that have the same ratio, right? And then an angle that's congruent between them. So this is going to be DEF is similar to HJK by side angle side similarity. So remember, when we're dealing with similarity, it means we get the same ratio, not the same length, okay? Versus congruence, okay? So let's see if you guys can do this one. Come back to me when you're done. Okay, so again, let's look at what we have. Looks to me like we have TX over VX, right? VX. So let's do, that's going to be 12 over 16, which reduces to be, 4 goes into both, right? 3/4, okay. Then we have this angle. Do y'all see this vertical angle right here? And so we're going to say that angle TXU is congruent with what angle? VXW, right? Angle VXW. Now we want to compare our other side, okay? So we're going to compare now this side, which we could say is UX over what? WX. Look right here. WX, okay? Last two. Over WX. Okay, UX was what? 15, and WX was 20. And again, this reduces to be, 5 goes into both, 3/4. And y'all, if they reduce to be the same number, which would be 0.75, that helps us out too. So now notice again, we have the same ratio. That's what we're looking for in a congruent angle. So this is going to be, yes, they are going to be similar. How are they similar? So this is going to be similar with VXW, right? By, again, side, angle, side similarity, okay? All right, the next one says explain why triangle ABE is similar to ACD and then find CD. Angle A, okay, so I want to show you all these triangles first. We have ABE, ABE, and then we have also ACD. So we have a little triangle and a big triangle. Y'all see them? Okay. So now when we talk about this one, we can obviously see that angle A has to be congruent with angle A. Can't we all see that? So angle A is congruent with A by the reflexive property of congruence. What is angle B congruent with? Look right here. B is congruent with C, isn't it? Because they're both right angles, right? And then, therefore, ABE is similar to ACD by angle similarity, right? We have two angles that are congruent. Now we're going to compare some sides, okay? So we've got CD here. CD that compares to what? BE. Y'all see it right there? So CE and BE, so that's X over 5, right? And that's going to be equal to, now let's see if we can find this other side. I'm going to do it in green. So we have CA. CA is the whole thing, right? And what is that whole measure right there, y'all? What's 9 plus 3 is 12, yes? So we got CA is going to be 12 over what? BA. Now, BA is the little triangle. Y'all see it right here? It's this, is here, the red one that I did originally red. See it right there? BA is 9, right? So we're going to put it over 9. We're just going to cross multiply here again, okay? So we're going to do 9x is equal to 5 times 12. So that's going to be 9x is equal to 60. So we're going to divide both sides by 9. So I got x is equal to 6.67. Okay, so now, again, we can compare these because we should be getting the same ratio, right? So if we look, and there's a couple ways we can do this, okay? So I'm going to show you guys both. So we could do 9 over 12 is equal to what? 9's a little, so it's 5 over 6.67. Are those equal? Well, when I did it, I got that they were both 6 points. What did I get? 1.33. Well, actually, no, take that back. It would be, that's 3, 4, yeah, this would be 0.75. So both of these are 0.75, okay? And again, you could have done it the other way. You could have put the big on top and the bottom, the little on the bottom, and that would have been 1.33, okay? So either way, you're just looking to compare, okay? That make sure that you get the same ratio to determine if the answer is the same, okay? All right, let's see if you guys can do this. Oh, let me show you the other way, by the way. So you could also do 9. No, never mind. Not for this one. We're going to do that tomorrow, okay? All right, so then this one says explain why RSV and RTU are similar and then find the RT. So hopefully you can see why. Pause the video and go ahead and do this. So angle S is congruent with angle T. We can see that in the drawing, right? Notice again that we have this angle R that's in both triangles, right? See the R and the R? So R is congruent with R by the reflexive property of congruence. Therefore, RSV is congruent to RTU by, again, angle, angle. Okay? So we're going to use some ratios to solve. So I want you to, again, see little triangle, big triangle, right? See this little triangle right here? See this big triangle right here? Okay? So we're going to talk about sides that relate to sides, okay? So hopefully you can see that if I say SV, last two letters, TU, right? TU. Okay, what does that equal to? SV is 8 over 12. We can leave it like that because we're just going to solve for the other side, right? We're going to solve for RT. Okay, so we want to compare, again, let's look at our letters. So we have RT, and that was the big triangle, right? So we're going to put that on the bottom because we have the big on the bottom because TU is part of the big triangle, right? And then we're going to see, what does that relate to? RT to RS, right? Y'all see that? So RS, okay, goes on top, little triangle, okay? So we're going to set that equal to 10 over RT, and we're going to solve for RT, yes? Now, I'm going to talk to y'all about that in just a minute, okay? So we can go ahead and set it up like this. We can set it up over 8 over 12 equals 10 over RT. Okay, so that's going to be 8 RT is equal to 120. Divide both sides by 8. RT is going to be equal to 15. Now, this is not the only way we could have solved it. We could have also made RT equal to X plus ST, right? But in this case, they're asking us for RT, so why not just solve for RT? Y'all got me? It just makes it more complicated if we do it the other way, so we're not going to do it that way, okay, on this particular problem. Now, if they asked us for ST, which is not what they asked us for, but if they did, then what we would do is we would have done 10 plus ST, okay? And that's how we would have solved it. So let's look at this last one, the last two actually. So it says engineering application. The photo shows a cable roof. AC is parallel to FG, and ABC is similar to FBG. Find BA to the nearest tenth of a foot. So we're looking for BA, which is right here, right? So we're looking for that whole length, okay? So we're going to take this side of the little triangle, and I'm going to show you how to do this again. So we're going to put that over BA. And remember, BF is BF, yes, but BA is what? What is BA? Look up there. Okay, pen. BA is 17 plus FB, isn't it? Okay, so this is 17 plus BF. I'm just going to put BF again, okay? All right, now let's compare that to two sides we have. So notice again, we have the little side, we have the little triangle right there, right? So that's going to be equal to 6.5 over our big triangle right there, bottom of the big triangle. That's over 24. Okay, so we're going to cross multiply this. So this is going to give us 24 BF is equal to 6.5 times 17 plus BF, okay? So when we do this, we're going to get 24 BF is equal to 6.5 times, let me see where I did the 6.5 times 17 was 110. So this is 110.5, and that's going to be plus 6.5 BF, right? So we're going to subtract this from both sides. Minus 6.5 BF. So that's going to give us 17.5 BF. 17.5 BF is equal to our 110.5. Then we're going to just divide both sides by 17.5, right? When we do that, we get BF is equal to 6.3, okay? And yes, it's 3.3, whatever, but it's 6.3, okay? So, again, what we can do is we could put that number back up here, right? 6.3 right there. And so isn't that going to be 23.3 for the whole length? So to check this, again, we would do 6.3 over 23.3 and see if that's equal to our 6.5 over our 24. It does check out, y'all. Okay? All right. Now, this last one says, what if? So we got AB, AC, BF, and find FG. Okay, so let's go ahead and erase what we had up here so we can label this stuff because we're not using the stuff that's in the drawing. Okay, so it says now that AB, the whole length of AB is 4x. Okay, and then it says AC. I'm going to put, that's part of the big triangle, right? So I'm going to put that down here. It's 5x. Okay, then we have BF, which is this little part up here, that is 4, and we're looking for FG. So that means we're looking for this. Oh, this one's going to be easy, y'all. Okay, so we can take big over big, or we could do 4x over our 4, right? And that's equal to, okay, we got our big again, 5x, right? 5x, and we're looking for FG, yes? So that's over FG. Okay, let's cross multiply this. So that would be 4x times our FG is equal to, right here, isn't that going to be 20x? Okay, how do we get rid of the 4x? We divide both sides by 4x, right? What happens to the x's when we divide both by the x's? Don't they go away? So what is 20 divided by 4? So FG is 5. Ooh, that's a tricky problem. I like it, y'all. I like it. Again, we can check this, yes? So if we were to put, and that makes sense, right? If this is 5, right? Because if this whole length over here was 4x, so that would be 4x over 5x is equal to what? Our 4 over our 5. Same values, right? Just take away the x's, you got the same answers.